Hello. Today we are going to start a new chapter, chapter 6, normal distribution. So this is like we have total 12 or 13 chapters, so we are nearly halfway through the semester. Uh, and so from chapter 6, all the following chapters and like chapter 6 and the later chapters are interconnected. So even if you could not follow the first 5 chapters, that's still a problem. But still, there is a chance to catch up. Or even if you skip chapter 5, still you can understand what happened, what's going on in the following chapters. But from now on, that would be impossible. Uh, so please, please pay more attention and get used to practice more because normal distribution is the most important basis, fundamental in any statistics. So let's just do a preview. We we already learned the binomial distribution in the previous chapter, and this chapter presents the normal distribution. These two are parametric distribution families. Remember, parametric distribution families are a scientific model that summarizes the whole distribution into a small number of parameters. So binomial distribution used two parameters, and also normal distribution uses two parameters. And when you compare these two distributions, there is a huge difference between them in their importance. So the normal distribution is the single most important distribution in not only in statistics but also in distribution is the norm. So that's why the normal distribution is called normal. All the other distributions are called like non-normal distribution, not abnormal. Well, anyhow, so normal distribution is so important. So the reason why I said it's important is because in this course, from now on, all the random variables will be approximated to a normal distribution. So in the later chapters, you don't need to know binomial distribution. Even if you don't know binomial distribution, even if you don't know conditional probability, not a problem. But if you don't know how to calculate the normal distribution, everything collapses. So you cannot cross the bridge, the river. There is a big big obstacle if you cannot handle a normal distribution. So almost every random variable can be approximated to a normal distribution under a certain assumptions. So that's why normal distribution is so important. Relevant book chapters. Read if you are interested, or if you simply type normal distribution on Wikipedia or on Google, you can see a lot of materials. So if you want more reading, please use online materials. To start, let's think about a simple question. There are 5 random variables, and one of them is different from the others. The first random variable is the amount of a tall size coffee. So you order a coffee and randomly choose a coffee, tall size coffee, and measure how much coffee is in there, like ounces. How many ounces of coffee is in the cup? Second B, the time when a bus arrives. So you may measure like the bus arrival time, like 12 o'clock or 1 o'clock or like 12 o'clock, certain minutes, certain seconds, blah, blah, blah. So, and third, C, the weight of a wild caught salmon. So pounds or kilograms or grams, uh, you can measure in many ways, and speed of a car on the highway, like miles per hour or kilometer per hour, meter per second, does not matter. And finally, number of traffic accidents on a day on a randomly chosen day. What is the number of traffic accidents, say in New York State? One of them is different. What is that? The intended answer. Maybe there is no right answer. You may think in a different way, but what I wanted was E. Uh, the E number of traffic accidents is a natural number or zero. We call this a discrete random variable because it takes on a countable number of values like this. Number of traffic accidents is countable, so it's a count. So it can take 0, 1, 2, 3, 4, 5. So there is a countable number of possible outcomes. But the other guys are called continuous random variables. They can take any value in an interval or any number. So when I say interval here, it can imply any real number when it is unbounded. Interval between the negative infinity to the positive infinity is another interval conceptually. So amount of a total size coffee can be any like positive number, like 1 ounce could be 1 ounce or 100 ounce. Of course, it would not happen. Its probability will be zero, but still, it can happen. Uh, And the time when a bus arrives is just a number. Weight also is a positive number. Speed is another number. So it doesn't need be a natural number or integers, but it can be any number like 1.000001. Any number is possible for these four random variables. That's the major difference. It causes this seemingly small difference causes a huge impact mathematically. So, simple way to distinguish a continuous random variable and a discrete random variable is this. When you choose two possible outcomes, then continuous random variable always has another outcome in between them. You can choose another outcome in between them. Like for example, suppose that you have two values 0 and zero point 0.01. Even if 0.01 is small, even if you choose a smaller number, still there is another even smaller number between 0 and 0.0001, right? So no matter how close to each other, there is another number in between them. That's one of the basic property of a real numbers. However, in discrete random variable, there is an increment, fixed increment. So like it can take 0 and 1 or 2 or 3. Then if you choose 0 and 1, there is nothing in between them. That's it. It cannot take zero point 0.5 or like 0.3. So the reason why continuous random variable is called continuous is because there is a continuum of outcomes. The outcomes cannot be divided into countable numbers. It's continuous. It exists continuously. So you cannot cut and you cannot find any increment between two outcomes. So we are going to study continuous random variable in this chapter. In the previous chapters, all the variables we considered was or discrete because it's easier. Discrete random variables are much easier to understand, so that's why we used discrete random variables only. In this chapter, even if the chapter is titled as a normal distribution, but maybe one third or half of these slides will be spent on explaining the difference between continuous random variables and discrete random variables. It is so important, and there is a huge difference between them. So uh, let's see what is the difference in the next video. Thank you for watching.